This section deals with proving trigonometric identities. So when you do this, you have your trig identity sheet that we'll pass out in class. So to verify each of the following identities, what I do is I start with the side that's messier. So the side that's messier, like more things that are with it. So for example, this one looks more complicated than this side. This side looks more complicated than this side. This side looks more complicated than this side. I start with the one that looks more complicated. Then what I do is I write each one of these in terms of sine and cosine. So first one, sine is already in terms of sine and cosine. Wrote that secant of x is the same thing as 1 over cosine. Cotangent is the same thing as cosine over sine. So I'm checking to see if does this equal 1. So I'm going to continue to go down the left-hand side and see if I end up with 1. So the next step I can do is I can cancel out cosine on the top and on the bottom and sine on the top and on the bottom. So I'm left with 1 equals 1. And that's it. I just verified that the left-hand side, which I simplified it, is the same thing as the right-hand side. Number 2. The side that looks messier to me is this side. So I'm going to write everything in terms of sine and cosine. So I have sine of theta, so that's already fine, over tangent. So tangent is sine of theta over cosine of theta. Plus cosine of theta, it's already good, over cotangent is cosine theta over sine of theta. So remember, when you're dividing fractions, what you do is you flip the second fraction over and multiply. So this is going to be sine of theta times cosine theta over sine of theta. So all I did is just flip the red fraction over, plus cosine theta over, cosine of theta times, I'm flipping this fraction over, sine of theta over cosine theta. So in the end, I'm going to cancel out my sine of theta on the top and on the bottom, and my cosine of theta on the top and on the bottom. So in the end, I have cosine of theta plus the sine of theta, which is equal to sine of theta plus cosine of theta. So this worked. It checked. The left-hand side is equal to the right-hand side. Okay, number 3. I'm going to write these in terms of sine and cosine. So secant squared theta is 1 over cosine squared theta minus secant squared theta, which is 1 over cosine squared theta, times cosine squared theta does that equal tangent squared theta? So I picked this one because I picked this side to do because this side looks more complicated and messier than this side. So once I did that, I'm noticing that cosine squared theta divided by cosine squared theta is just 1. So I have 1 minus cosine squared theta minus 1 equals tangent squared theta. Or I shouldn't say equals tangent squared theta. We don't know if it equals tangent squared theta yet. So I'm still working with this blue part, simplifying it. So to simplify, remember when you're subtracting fractions, you want to get a common denominator. So in order to get a common denominator, I'm going to multiply the bottom by cosine squared theta and the top. So if I look over here, if I have 1 minus cosine squared theta over cosine squared theta. So 1 minus cosine squared theta is very similar to cosine squared theta plus sine squared theta equals 1. That's an identity. So the top part is actually 1 minus cosine squared theta is technically, see if I subtract cosine squared theta from each side, that's equal to sine squared theta. So this red part becomes sine squared theta, and I still have a denominator of cosine squared theta. So remember that sine over cosine is equal to tangent squared theta. So this is tangent squared theta, which is what I started with. So I verified the identity. So I used a Pythagorean identity. Now, there's different ways that you can do these. So now I'm looking back, and maybe I should have, another way I could have done it is I could have factored out a secant squared theta and done it that way. And then I would be left with 1 minus cosine squared theta, which is sine squared theta. I could have done it multiple ways. You can do all these multiple ways. So number 4 is, to me, I'm going to go through and write all of these, this side in terms of sine and cosine. Actually, I'm going to do both sides. This side's messier. I'm going to do tangent squared theta plus 1 in terms of sine and cosine. So I have tangent squared theta is sine over cosine squared theta. Now, when I add fractions, I need to get a common denominator. So I'm going to have cosine squared theta over cosine squared theta. Now, this numerator is a Pythagorean identity, which is 1. So sine squared theta plus cosine squared theta is 1. So now I have 1 on the numerator, and my denominator is still cosine squared theta. So remember that the reciprocal of 1 over cosine squared theta is secant squared. So this is equal to secant squared theta, which is where we started, or what we're trying to verify. So it checks. Okay, number 5. I'm going to write these in terms of sine and cosine. So cosine's good. So I have cosine theta. Secant is 1 over cosine theta minus cosine theta. So if I distribute, cosine of theta times 1 over cosine of theta is just 1. Cosine theta minus cosine theta is 1 minus cosine squared theta. Does that equal... Oop, I want to go jump ahead. Okay, so now I'm going to go back to my Pythagorean identity, which is cosine squared theta plus sine squared theta equals 1. So if I subtract cosine squared theta from each side, this is equal to sine squared theta, which is what I'm trying to prove or verify. Okay, number 6. I'm going to write again in terms of sine and cosine. So cosecant theta is 1 over sine theta. Tangent is sine over cosine theta. When I multiply these two will cross out, so I have 1 over the cosine of theta, which is equal to the secant of theta. So it works. Number 7, cotangent theta, secant theta. So I'm going to go through and I'm going to write this in terms of sine and cosine. So cotangent is cosine theta over sine theta. secant is 1 over cosine of theta. So the cosines cancel out, so I'm left with 1 over sine of theta, which equals cosecant theta, which is my original problem that I need to verify. Okay, number 8. All right, so I'm looking at this one. It's already written in terms of sine and cosine. So I'm noticing that I could actually distribute this, FOIL it, and I'll get 1 plus sine of theta minus sine of theta minus sine squared theta for this side, this messier side. So if you notice, these two will cancel out. So I'm left with 1 minus sine squared theta, which goes back to our identity. Cosine squared theta plus sine squared theta equals 1. So this is equal to cosine squared theta, which is what I was trying to prove. So in all, what you want to do is you want to write the terms, you write them in terms of sine and cosine, and try to get things to cancel out. Remember to add fractions, you need to get a common denominator.